the first mistake that I'm going to see made is people are going to try and take the natural log of both sides. You can. You'll end up with the right answer, I think, provided everything else turns out okay. This problem can get really, really ugly if you don't really know what's happening. 25 and 5 should have a common base. What base do 25 and 5 have in common? Ty? 5. The 25 is really 5 squared to the x. And that's going to equal 5 to the x squared minus 15. Okay, now that I have Teacher Joseph, now that I have two exponents being raised to each other, what do I do with those exponents? Multiply them, obviously, right? Like ice cream needs to be in the freezer, obviously, Teacher Joseph, is that right? Sure, good. Now that I have the same bases, what can I do with those exponents? Chief? No, not combine them. Cancel the bases and set the exponents equal to each other. 2x equals x squared minus 15. I'm going to subtract 2x from both sides. So I get x squared minus 2x minus 15 equals 0. So I get x minus 5 times x plus 3. X equals 5, comma negative 3. And that's all there is to that problem. 76, dead. All right, 114. On the next page. Yes. We didn't cover this in great detail, but one thing we have to use for this problem is what's called the change of base formula. The change of base formula says that this answer here is the same thing as taking the common log or natural log of the answer divided by the common or natural log of the base. So I will trust that you guys can do that in your calculator. Remember, it's the natural log divided by the natural log. It's not the numbers divided by each other. So it's not 21 divided by 5. It's the natural log of 21 divided by the natural log of 5. I'm going to let you guys handle that. I'm going to backtrack and actually do number 113 because it's the same type of problem. Log base 2 of 11. Anyone know how I deal with log base 2 of 11? What does that look like? Chris? There you go. All right. That's how you do those problems. Change of base formula is what you need to keep in mind. 117. Okay, I understand the problem with number 117 because it says use logarithms to figure out the answer. However, there is one thing that you guys should probably keep in mind. What do all the bases have in common? They're all the same, right? And they're all 5. So that means that if the bases are the same, don't the exponents have to be the same also? Yeah? So, we know that something's going to equal negative 18. Let me ask you guys a question. 5 times 5. What's happening to those exponents? The bases are being multiplied. What's happening to the exponents? Ty. They're being added. So this is x plus negative 7x. That's easy. That's negative 6x equals negative 18. X equals 3. That one was a not so obvious problem, okay? That's definitely not in the vein of putting ice cream in the freezer. Okay, let me type up this next problem here. Hold on, let me pause it. A substance decomposes radioactively. Its half-life is 32 years. Find the decay constant. Okay, this is a PERT problem. A equals P equals E R T. Okay, this is a half-life problem. And it's asking us to find the decay constant. So when we're dealing in half-life, typical half-life problems mean that a substance is going to have half of its normal composition after a certain amount of time. What role does 32 play in this problem? Time. What's E? E. Now, what are A and P? In these half-life problems, they don't give you A and P, but they need you to find it on your own. If I start off with, Cameron, let's see, if I have, in this order, yeah, backwards, right? Because if I have 2 particles of radioactive material, I'm going to have 1 by the time it's all over. And R, we're trying to find the decay constant, so that's what we're trying to find. So this is going to be 1 equals 2e to the R32. I'm going to divide by 2 on both sides. I get 0.5 equals e to the 32r. I'm going to take the ln of both sides. Here's where people are going to start making their mistake, and I saw this a lot actually yesterday. They forget that you're taking the natural log of 0.5. They just kind of cancel this e. It's the natural log of 0.5 equals 32r. And then you divide that by 32. So who can give me the natural log of 0.5 divided by 32 rounded to 3 decimal places, please? Dom. Okay, yeah, why not? Let's go to 4. Now the rate should be negative. Why should we expect a negative rate on this, Nate? Because it's degrading. It's decaying. Degrading is like when you insult someone. Like if I say all such and such types of, persons are, worse off than such and such types of persons, that's degrading. Decaying is what you're looking for. 131. Dead. 153. Write the terms. Okay, this is a quiz problem here. Oops. Because they're asking us to physically write the terms, unfortunately we have to kind of muscle this out. From n equals 1 to 6 of n plus 2, we have to muscle it out. We can't just use a formula. It's asking us to write out the terms. So where n equals 1, I'm going to have 1 plus 2. When n equals 2, I'm going to have 2 plus 2. When n equals 3, I'm going to have 3 plus 2. When n equals 4, I'm going to have 4 plus 2. How high am I going with this? To 6. When n equals 5, I have 5 plus 2. And when n equals 6, I have what? 6 plus 2. 3, 4, 5, 6, 7, 8. 7, 14, 14 plus 11, 25, 29. Right? No, wrong. 7, 14, 11, 25, 31. Sorry, thank you. 162. Where are we? Find the nth term of the geometric sequence. So, 162 says a sub 1 equals 200, r equals negative 1/2, and n equals, darn it, 10. We need a formula for this. We need the sequence formula for a geometric sequence. So it's going to be a sub n equals a sub 1 times r to the n minus 1. So we're trying to find the nth term, which means we're trying to find a sub what in this case? A sub 10. And that's going to equal a sub 1, that's 200, times r, which is negative 1/2, to the n minus 1, so to the 9. What's 2 to the 9th power? Say again? 512? What's 512 divided by 200? That's not going to go in evenly. Or, I'm sorry, someone give me 512 divided by 4. 15? 50? 512 divided by... Wait, 512 divided by 200 is 50? That can't be right. 512 divided by 4, please. 128? So that is 50 times negative 1 over 128. Okay, so that means that this is 25 and this is 64. So this is negative 25 over 64 is your 10th term. I was just reducing there. That's all I was doing. Just to make that clear. Just reducing those fractions. Bam. 178. Express the repeating decimal as a fraction. 5, 5, 5, 5. Okay. A sub 1 is 0.5. A sub 2 is 0.05. Who can raise their hand and tell us what is A sub 3 in this problem? Skylar, you know what A sub 3 is? 0.005, right? Because if we just compress them all downward, they're going to, form this 5, 5, 5, 5. Okay. How do you find R? Chris? Not minus. Divided, right? A sub 2 divided by A sub 1 or A sub 3 divided by A sub 2. What is R in this case? What is R in this case? Should be 0.9. 0.1, right? Alan, I think you were a little bit ahead of the game. So this is all the information we need. The sum is going to be 0.5 over 1 minus 0.1, which is 0.5 over 0.9. Now, we can't have any decimals, so multiply the top and bottom by 10. So we've got 5 over 9. Someone do me a favor, put 5 over 9 in your calculator and tell me what you get. 0.555555555. Yep. 188. Okay. Gosh, 188. All right. X minus y to the 7th. All right, for this, you can either use the binomial expansion formula or you can use Pascal's triangle. I don't know. I find Pascal's triangle to be faster. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You know what? I did this problem in period 4 already, so just watch that, all right? I did this problem in period 4 already. But basically, you just do the coefficients and then all that good stuff. I'd rather spend time on something like number 193. That's more worth our time. Find the 7th term of 2x minus 3y to the 10th. Okay, what is the formula that we are going to use for this binomial expansion? What's the formula we're going to use? Anyone remember what that formula is? Do I need to start subtracting points from your pop quiz? Chris? From sigma from k equals 0 to n? Factorial? b to the k, right? Okay. Now, here is the most important thing. What is n in this problem? Julia, what is n? Good. Julia, do you know what k is? 6. Why is it 6? 1 less than what they're asking you to do. Good job, Julia. Vicious would be very proud of you. Okay. Anyway. Now we just got to pump it into the formula. So this is from sigma from k equals 0 up through 10. So n factorial is 10 factorial over n minus k factorial times k factorial. A to the n minus k, so that's a to the 4th, b to the 6th. Okay, let's take a look at the coefficient. That's 10. Oops, sorry, what am I doing? It's not a and b. What are a and b? What's a? 2x, right? To the n minus k, and then negative 3y to the k. Oops, to the 6th. Okay, let's figure out the coefficient first. 10 times 9 times 8 times 7 times 6 times 5. 4, 3, 2, 1, all over. 10 minus 6 is 4, so 4, 3, 2, 1 times 6, 5, 4, 3, 2, 1. Yes? Gone? Do we agree with that? 4 times 2 is 8. 9 divided by 3 is 3. 10 times 7, 70, 210. Times 2x to the 4th is going to be 16x to the 4th. What's 3 to the 6th? Is it 243? 729. Which one is it? Let's forget. 3 to the 6th? 729. So 729y to the 6th. So what I need, 210 times 16 times 729. Raise your hands as soon as you got that. Chief? 2449 440. X to the 4th, y to the 6th. Julia, you had a question. You may not leave the syndicate if that's what you're asking. Yes, however, what's a negative raised to an even exponent? Positive, right? Okay, cool. 190? Yeah. Okay, that one's easier. Okay, 190.